Here's a table scan from the update. Note that it looks just the same. It says table scan. The only real differences are it says update instead of select. And at the tail end, we're saying to table, which is the table that's being modified. Why might it do that? It might do that because you might have a join in your update and not know where the target is going to be going. Now, as we're getting into single table optimization, we also have to discuss the concept of partitioning. Partitioning is new for 15. The idea behind partitioning is sometimes the tables get so large that querying the table, modifying the table, whatever it is we need to do with the table, is going to become more difficult because of the volume of data. If we're going to do a table scan and we've got, a terabyte of table, it's going to take a very long time to scan that terabyte of table no matter what else is going on. So we take the opportunity to use the partitioning for purposes of identifying we don't necessarily need to get there from here right now. We're not going to be using all the data today. We are going to be putting some set of data on less expensive storage. This amount of data, or this portion of the data, is active and volatile, so we need to update stats on this part. We don't have to update stats on the non-volatile portions of what's going on. So we'll talk about the partition support. Once again, I'm going to go through this relatively quickly. This is about half an hour all by itself if we're doing this by itself in a presentation mode. Semantic partition support. We've had partition support with ASE in the past. The semantic partition support in particular says we are going to be defining rules which are going to describe how this information is set up. Gives us the ability to take the data in the tables and put them into manageable pieces. Different types of semantic partition includes horizontal partitioning that says, let's go ahead and take these things and put them on different devices. Semantic partitioning allows us to say, we're going to define keys, and based on what's going on with those keys, we are going to determine where the partitions are going to be assigned. Partitioning strategies, again, these are for the semantic partitioning, include hash, list, range, and round robin. The first three are semantic partitioning, and the hash, list, and range are the new ones. The round robin really is what was going on before. Hash partitioning says, I am going to supply a hash function which is going to determine the partition assignments. This is for when you want to specify a relative round robin, but give yourself the ability to do a little bit more in terms of indexing. The list partitioning is when you want to, for example, say, let's put information for California, New York, and Texas on this one device, and every other state on another device. Well, at that point, we have a list, and we say, okay, these are the more populous areas, and these are the least populous areas. Let's divide things out that way. The range partitioning is similar to the list partitioning, except you're giving it a data range instead of a list of values. So 0 through 1,000 goes here, 1,001 through 5,000 goes there, everything else goes over here. Gives you the ability to divide things out very well. How you do your partitioning is going to vary, at least in part, along with how you are going to be accessing the data, as well as how you want to do things like archive the data. So partitioning strategies allow things like create table and create index commands to be used with the partitions. The alter table can change the partitioning strategy. Add partitions, alter table add partition builds these things up. And we've got the ability to do a lot of different slicing. So prior to 15, what the partitioning basically allowed you to do is to create separate page chains. And creating separate page chains did have some advantages. You could, for example, say, I want to spread the I/O across these devices for insert, have 3 separate insert points, and spread things out that way. Having these partitioned prior to 15 also increased your parallel query performance, parallel check storage performance, parallel index creation. A lot of this stuff worked faster simply because things were set up to go onto separate disks at separate points in time. Now, there's this myth here down at the bottom that says those are no longer useful due to the SanDisk speeds. We do disagree with that because the data row and the partition tables are faster for inserts. significantly because you end up with that issue of, or the benefit of having multiple insertion points. Now, with the advent of 15 in the semantic partitioning, what ends up happening is we can get a lot more specific about where things go. So we can say that first partition gets A through I, the second partition gets J through R, the third partition gets S through Z. What does that do for us? That takes the alphabet, of course you know it's the alphabet. It takes our customer list, for example, and says, okay, now that as we're accessing the customers, we're hoping to take about a third on each of the physical device structures. This is a good thing. We also have the ability to partition the index structures. So I can take the indexes and put them on the individual areas. So rather than have one index on A through Z, I can have an index on A through I, and an index on J through R, and an index on S through Z. This gives us the capability of having much smaller index structures than we had before, and also much less deep, much shallower index structures. We can have one global index that goes after everything, or a bunch of local indexes. Why would we want to use one over the other? Well, the local indexes are going to be quicker, but the global indexes will allow you to do things like enforce uniqueness constraints across your entire data population. Improved query support. The optimizer got a lot smarter to use the semantic partitioning. The optimizer is probably the one thing that changed the most and it gives you the most benefit for your SQL, your ASC updates to 15. Also note that the maintenance is partition aware. So let's say you don't partition based on name, you partition based on date. And you make the decision that everything that is older than a year, because we don't touch it much, is going on a separate partition. Well, guess what? Maybe in that case, all you end up doing is performing your reorgs, DBCCs, BCPs, etc., out of that more recent partition. Here's syntax for that. Range partitioning example. And again, I'm going to go over this just quickly to show you what we've got. Here we have three separate partitions. One is less than or equal to 20,000. The next one is less than or equal to 40,000. Note that that second partition will start right at 20,001. Note also that we don't have a range set up that includes 60,001 because we don't have one set up for 60,001. If you try to insert that row, you will get an error. So as you're defining partitions, you need to pay attention. Index partitioning. Indexes on the partition table may or may not be partitioned. We do recommend that you partition them where it's useful unless you need to do this to enforce uniqueness for one reason or another. Terminology. Local index is a partitioned index, which means we have the index on the partition rather than having the index on everything. The global index is what you're looking for overall. So, quick example of the local clustered index. We have everything on their own separate segments. And yes, we're still using segments with partitions. For the non-clustered global, we have one index structure. It may or may not be in a separate segment, and it is pointing to things in all the other segments. By the way, you may get a copy of this upon request if you want to go over these and slow-mo through the slides. Why is the partitioned index faster? Well, the partitioned index is faster because we have the ability to use smaller index structures. If I'm only going after one index, which is significantly smaller, we may have to go through only 3 levels instead of 5 or 6. Note that we also end up single threading through our root a little bit less. So local indexes versus unique. Note that if your local index is on whatever it is that you're looking at, for example, here we're on California and your local index is on state, well, guess what? We know that we can get uniqueness there. But if we have an index on customer number and we're partitioned by state, then what's going to happen is you do have the potential of having a customer number in the state which is not unique. So that local unique index is something that you have to watch out for. Oh, solution to that, of course, is to make it a global index. Note that ASC warns rather than enforces. The reason that it warns rather than enforces is it gives you the ability to make the decision as to how it goes. Therefore, instead of 10 partitions,